Hello, everyone. Thanks for joining our session about the project we are actually working on right now. And the project is about building an operational monitoring platform for mobile network operator in Poland. So first of all, let me introduce ourselves. My colleague, Maciej Bryński, who is our big data architect and actually working as a tech lead on this project. He's going to explain the technical details behind the platform. And myself, Rafał Małani, I'm going to share with you a broader context of this project. We both work in getting data. I'm sure you've heard about Facebook outage that happened recently due to misconfiguration of network devices. It was broadly commented in news all around the globe. Some headlines pointed out how we are dependent on globally on the social network and related apps. And actually, we gained a few hours of our life that we could spend our way, but a bit disconnected. What is interesting is how this impacted the mobile network operators. One of them has published some data on how Facebook outage impacted their services. So we have pretty obvious increase in texts, like plus 100%, voice, decrease in data. But what is the most surprising is the number of phone calls to the call center that has increased 8 times. People are asking why their Facebook app isn't working. Customers somehow related services provided by software company with the service provided by telco operator that has actually nothing to do with the software that uses the network. Why that happens? Because we started considering mobile network access in terms of utilities like electricity or water supply. Having good quality connection is something normal for us nowadays. Not something you would especially appreciate and call your operator every day to say thank you for providing this good quality service. But when it's gone, it does not feel normal anymore. And people get frustrated and actually complain a lot. Obviously, there are some side effects of being constantly connected, but we're not going to touch this here. But it is not only about Facebook, emails, music streaming, entertainment, and work. Many services that are provided to citizens and communities are highly dependent on mobile network. And I don't mean services like Uber Eats that we can actually live without, but the ones that have significant impact on our lifestyle and even safety, like emergency numbers, like 112, number 112, ATMs, mobile banking, just to name a few. I'm sure you know that in Africa, mobile banking is huge. It's much more popular than like traditional banking. And 5G is going to hit us soon, opening a much broader range of possibilities and actually functionalities that can be implemented and used. By the way, do you know that over 50% of web traffic comes from mobile now? I didn't know that. In mobile-first continents like Africa or Asia, it is almost 70%. Coming back to Poland. Poland is an average-sized country in Central Europe. We have over 38 million of citizens, and statistically, around 1.36 subscriptions per person. We have 4 mobile network operators, and actually 2 of them, like 10 years ago, has agreed to join their forces in developing shared radio access network. So they set up a joint venture company called Networks that is responsible for maintenance and development of mobile infrastructure for these 2 telcos. They maintain over 500,000 cells plus the network between them. And one of the crucial processes in Networks related to maintenance of the shared radio access network and the transmission network and all the devices included, that actually has a direct impact on the quality of service that you provide, is handling performance and configuration data. As mentioned previously, there is over 500,000 devices out there, but it's not only about high numbers of devices, but actually the variety of hardware coming from different vendors and providing different technologies, like different technologies in place, actually, like 2G, 3G, and all other flavors. So actually no standardization in logging. That's the biggest problem. But to monitor network efficiently, you need standardization. So there was a need to provide a common data analytics solution that would be able to standardize data models, perform aggregations, and compute KPIs measures for not only quality control, but also for further automation and configuration management. So a few years ago, they have built a typical data warehouse based on Oracle that covered the whole process from data ingestions through processing like aggregations, KPI computation, to data standardization, and actually providing a unified model and unified interface for analytics and all data science needs. Use cases like, as mentioned before, network optimization and planning as well. The main difference between NetCube, as they called it, and a typical textbook warehouse is the number of fact tables. If you compare it to a typical data warehouse like supporting finance or sales, they have much less fact tables than NetCube has. And it comes from a huge number of network events, different types of network events, and vendors and technologies. Last but not least, it has to provide also some separation on data level, as from actually a legal perspective, although the infrastructure is shared, these two telcos are formal competitors. So from the legal point of view, they cannot actually see each other's data. One of the most important goals of the data warehouse was to actually minimize data processing latency and in effect minimize the time between a network event occurrence and availability of the data correlated with this event in database. So from raw data to KPI, published KPI. This obviously looks like a streaming use case, but current technology had its limitations. And to be honest, the amount of data they're dealing with databases is quite significant. Right now, we have almost 100 million events per hour. The warehouse is pretty complicated, like all structures are metadata driven and versioned, so you can change actually the way KPI is calculated and reprocess part of historical data to get updated insights. And thanks to this versioning, you can actually compare, apple to apples and peers to peers. Having a relational database in place, they were trying to achieve as close to real-time processing as possible to better serve their need, but actually they were not much successful in that. There was another problem. Oracle was reaching its performance limitations, mainly in terms of on-the-fly calculation of these measures, KPIs, for network elements, and actually triggering alarms in case of certain threshold is violated for the current workload. There was also no way to accommodate more data that they were expecting. So keeping in mind that we have 5G just around the corner, they predict the amount of data is going to increase dramatically and due to network growth. So they with the current solution, they were not prepared to accommodate that. So they decided to switch to another technology, not only for performance and capacity reasons, but also possibilities to implement new features. And this is how we started last year working on the project, replacing ingestion layer. And the project is called actually NetStream.
When developing stream processing application, you should ask yourself 4 main questions: what, where, when, and how. What results are calculated? Where in event time are results calculated? When in processing time are results materialized? And how do refinements of results relate? Those questions were explained in details in book you probably know, Streaming Systems. When thinking about stream processing platform, the questions are similar. What is the current state? What data and metadata we have? Where to deploy stream processes? What kind of hardware can we use? If we will be running our platform on-premise or in the cloud? how to process the data, what kind of processes should be implemented, when processes evolve, how to manage change in data structure and metadata. In next slides, I will answer those questions. Let's start with what. In networks, we have a lot of data. Company uses many different types of network devices from different vendors and providing different technologies to the users. In total, that gives us around 750 different data sources with 500,000 devices. Every device saves its metrics like number of users logged in or amount of data transferred periodically. Every record has its own primary key and one or more metrics. It is possible that some records can be created twice. Currently, data is put straight to the Oracle database. The duplication is done thanks to primary keys in DB and merge into operation. Huge amount of different types of data has its impact on current solution. Networks using Oracle database for data processing, and all the processing is configured in metadata. There are two main types of jobs, aggregation and KPIs. The difference between them is that aggregation is much simpler. Mainly, it provides ability to run queries like select some kind of aggregation, like maximum, minimum, average, or sum, from one data source, group by device and time window. KPIs gives option to run any SQL query, but is more complicated to configure in metadata. Important thing is that the metadata evolve in time. KPI queries can change, as well as the aggregation function on column definitions. The second question is where. Networks has their servers on premise, so we built our processing platform based on Kubernetes and HDFS. They were known to be good fit for on-premise environment. We are putting all the data created by network devices to Kafka. We are using Flink deployed on Ververica platform to handle data processing. For processing purposes, we have data stored on HDFS, saved by Kafka Connect. We are also using Clickhouse for analytics. There are a few architectural decisions we need to make here. First, which data processing engine to use? Is it Flink, Spark Structure Streaming, or Kafka Streams? Second, which resource manager to use? Is it Kubernetes or Yarn? Third, how to save data for processing purposes? And last, what analytics database to choose? Is it Druid, Peanut, Clickhouse, or maybe just use distributed query system like PrestoDB? I will answer those questions during the next slides. From the analysis of current state, we created the list of processes that need to be handled by the platform. First is the duplication. This is done currently by merge into statement in Oracle, but due to performance reasons, we wanted to offload this job. Then we have aggregations and KPIs. We wanted to mimic current behavior and use the same metadata for the processing. We introduced new process, Oracle ingestion, as we need to save data from the Kafka. And we need to create data reprocessing tools in case something went wrong. This is the data flow we have implemented. Blue fields are the Kafka topics. We have many of them. In fact, it's around 750 topics per processing stage and around 3,000 altogether. We choose to have one topic per data source per stage. All the data is serialized into Avro format, and we are using schema registry. Data is processed in following stages. First, we have the duplication. Then the duplicated data is used by three kinds of processes: ingestion, aggregation, and KPIs. In the last stage, aggregation and KPIs results are saved to Oracle by another ingestion processes. The first stage on the path is the duplication. There's only one instance of process for that. We are assuming that every message has a unique key stored as Kafka key, and the key is calculated as hash of primary key columns, so device ID and timestamp. So two messages with same Kafka key are the duplicates. This is a very efficient solution as we don't need to deserialize message to make the duplication working. We just read and compare byte arrays. The duplication process is built based on DataStream API and stores data in RocksDB. Creating the duplication process, let us make some architectural decision. First, the duplication job from its definition should process every element exactly once. So exactly one semantic for whole pipeline was needed. This will route Spark structure streaming, as it has no option for that. We also don't want to use Kafka streams, as it's creating a lot of topics for internal purposes, and we have 3,000 of them just for the data. During implementation, we had many challenges and problems, most of them caused by large amount of data and number of jobs. I will cover this topic in parts after every process description, and let's start with the duplication. We had two main issues here. First, the duplication job has exactly one semantic. This feature is implemented in Flink, but you should be extremely careful at the boundary between Flink and Kafka. Proper configuration is needed on both sides, and you also need to configure all the consumers to read only committed data, which is not a default option. The second problem was much more difficult to solve. We had a big problem with performance. When state size had grown significantly, we saw big impact on number of events processed. From the monitoring, we realized that the disk is probably the bottleneck in the process. So, first approach was to use state TTL to decrease the state size. But still, we were able to process around 1,000 events per second per thread. Then we moved data processing from SSD to NVMe disks. This gave us around 3 times boost in performance, but it wasn't enough. The solution was to change RocksDB configuration. For unknown reasons, default Flink RocksDB profile for SSD is not using Bloom filters. Enabling this option gives us final performance, 8 to 10,000 events per second per thread. On the diagram on the right, you can see 3 steps of increasing performance: before changing RocksDB options, after change, and third one, after increasing also the CPU limits. After the duplication data is used to calculate the aggregation KPIs, both kinds of processes are similar. We have one Flink job per every calculation, and we are using mainly Flink SQL with some data stream API involved, as we wanted to use current metadata. Aggregation was the most difficult part in the project. We have a lot of jobs, around 2 to 3 jobs per data source type, so 2,000 in total. First, we make a choice that we prefer Kubernetes and Ververica platform over Yarn. Ververica has REST API, so we were able to create some tools for automation. Then we create scripts in Bash with configuration in Yarn to handle job creation. This is the first way of automate this. And the later approach was to create NetStream operator. I will talk about later. The second problem was continuous data reading from Oracle. Because of the size of the database, we can't use Debezium for CDC because the miner was unable to process all the data. So custom connector, similar to Kafka Connect JDBC store, was created. Then we came into Flink major version upgrades. Maybe you don't know, but Flink SQL is very strict when state evolution and major Flink upgrade. It can cause situation when you can't read your save point. Also, our NetStream operator was the workaround here. Fourth problem was handling of late data. The business requirement was to handle data as old as 5 days and calculate updated aggregation and KPIs for them. In Flink SQL, this is not an option. If you are specifying event time, then you need to specify watermark. If the watermark is small, like a few minutes, then late data is dropped. If the watermark is big, like 5 days, then calculation won't be sent before watermark arrives. And you don't want to have 5 days of delay in your streaming pipeline. Workaround for this problem was using time column as normal grouping column, not specifying event time and watermark, and set TTR for the pipeline. And the last but not least, we spotted many bugs in every tool we used, but I think this is unfortunately normal in big data world. So, what are the most interesting bugs? Some of our data sources has a lot of columns. The maximum number was more than 800. And Flink had problem with that. We get a compilation error, method size grows beyond 64 kilobyte limit. This is fortunately solved in Flink 1.14, but we still need to upgrade to this version. We have also problem with math function on decimals. Currently, functions like log or x gives results as double, so we're using precision. As a workaround, we created UDFs with own implementation of that functions. There are more bugs, and I can spend the rest of the presentation talking only about them, so maybe let's move to another topic and another process. After the data is processed, we need to save it to the Oracle database. Our first approach was to use Kafka Connect JDBC connector. Unfortunately, there is not exactly one implementation in it. So we need to switch to another solution, and we have two choices. First, implement own Kafka Connect connector, or create Flink process. Fortunately, this is the moment when Flink XA JDBC connector came in. We found it on the Flink GitHub as merge request in progress and backport to Flink 1.12. Then we created own ingestion process based on this connector, and after upgrade to 1.13 and some bug fixing, we remove this backport from our code base. The only thing that still needs to be included in official Flink code base is the ability to handle multiple table destination by JDBC sync. So we created this code and in the project, but merge request is stalled and need to be merged. For operational rational monitoring, we are using Clickhouse. Ingestion process sends information about consumer offsets to special topic, and Clickhouse is reading both raw data and the information about what was consumed from this topic. Then we can join those data sources and calculate statistics of ingested data. This gives possibility to monitor network devices in real time and create alerts when there is no data in Oracle from specific device. We choose Clickhouse over Druid, Peanut, and PrestoDB because of following reason. Clickhouse was very easy to deploy on Kubernetes. There is Clickhouse operator for that. Compare this, for example, to Druid. Clickhouse handles other decimal types. It supports join operator, and it's super fast. The only feature missing is upset, but we don't need it yet as we maintain exactly one semantic in the pipeline. Sometimes there is a need to reprocess part of data, for example, because of the metadata change. We did two things to make this possible. First, we saved data from Kafka to HDFS using Kafka Connect. And second, because we are using Flink SQL, we can just replace source table in SQL and our processes are still running properly. We choose Kafka Connect in the same time like for ingestion, but here Kafka Connect was good enough for the task, so we didn't switch to Flink. The only problem we had was handling of other logical types, but we find a patch on GitHub for that. I don't know why this patch is not included in Kafka Connect codebase, but in our case, it's working properly. We also deployed Rundeck as a user interface for launching common tasks like reprocessing. And the last topic that I want to cover today is change management. As I mentioned earlier, Flink SQL has a big problem with state evolution and upgrades. We also have a lot of jobs to manage, and first solution, which was the bash script, was not ideal. This is the moment we created NetStream operator. All our jobs are deployed on Ververica platform. Operator is reading desired state from metadata DB, then compare it with current state from Ververica API, and then apply the changes needed on Ververica. NetStream operator can handle creation of new aggregation and KPI jobs, modification of existing jobs, and Flink version upgrades. So how the upgrade is working? To handle upgrades, all the jobs have ability to set minimum and maximum timestamp of processed data. This is simple SQL where condition on the record timestamp. So upgrade process can be split into three phases. First, operator restarts current job and add maximum timestamp condition, for example, for the midnight of the following day. Second, operator creates new job with new logic or new Flink version with minimum timestamp condition. This job is started with clean state, and this gives us two jobs processing distinct time intervals. Few hours after timestamp condition is met, for example, on 5 a.m. following day, or the job is removed.
Okay, so a few words about the future of the project. Currently, we are deploying the solution on production, so business users will actually start working with the new solution around December or early January next year. However, we have already some plans for additional features. We're thinking about setting up an alerting mechanism that will be able to automatically start incident management process, so something a bit more than currently on the Clickhouse implemented. The other scenario covers predictive maintenance, or generally speaking, the ability to run machine learning models on the stream, and in the future, ability to retrain the model on the fly. This also covers recognizing patterns that leads to future outages, so the organization can, first of all, learn and adapt on the fly to avoid larger problems in the infrastructure. There's also there are some interesting cases regarding some suspicious behavior of users that can be also recorded and found in the data. Last but not least, the strategy of the company in the long period assumes that the current setup with Oracle, being actually an access layer to computer data and to the NetCube, this approach will be reevaluated. However, we are pretty sure that once the actual business user starts using the platform more intensively, they will come up with more ideas, and the ideas how to improve or extend it. Thank you for your attention. If you have any questions, we'll be happy to answer them. Thank you.